In order to become the competitive system software engineer, understanding of the cache is important because at the hardware level, an understanding of the cache can impact the performance. And then if you add a piece of code based on the concept of the cache, and you will maximize your performance. In this lecture, you're going to understand what the cache is. What is the cache? Cache is temporary store that frequently accessed or nearby data. And one of the well-known examples to maximize performance is to use the pre-patched data. The pre-patched data can be stored into the cache memory. So the frequently accessed data is stored into the cache. If your routine, your model, your function first access the cache, it will maximize the performance. Cache is generally placed between two levels of memory with a significant difference in the performance. This is a typical example of the cache that is placed between processor and the main memory. The ARM core first access the cache instead of main memory to access the data inside the cache. Caches can be implemented in either software or hardware. Generally, when you consider the cache, many of the concept of the cache is CPU cache. CPU cache can be implemented at hardware level, but number of the software model can be implemented using the feature of the cache. Let's explore the example of cache implementation. At the software level, then you may hear about the slab cache. Slab cache is one of the features in the memory management system that is designed to pre-allocate the memory that is frequently allocated. Another widely used cache in Linux kernel is the page cache. Page cache is designed to store the data of the file, and that can be expected to be accessed frequently. At the processor level, and there is linked register cache or branch cache at the hardware level. To maximize performance, the cache can be implemented at software level and the hardware level. You can find a number of examples that is implemented using the cache. When you think about the designing your software using the philosophy of the cache, and we have to think about the three questions. First question is how to locate the desired data in the cache. And cache is generally store the recently accessed data. Then if you think about designing your own model using the cache, you have to think about the pattern of the data that is recently accessed. Another design philosophy of the cache is the cache miss. Cache miss happen when the desired data is not available in the cache. So you have to think about how to implement your cache if the cache miss occurs. The two important concepts you have to remember is cache hit and cache miss. If the data is located places found in the cache, and then cache, you can say that cache hit is taking places if the desired data you're looking for is not located in the cache, and we can say that cache miss occurred. Another thing you have to think about is how to optimize cache performance. In the CPU, cache and multi-level cache is designed to maximize performance. So in this lecture, and you have understand what the cache is, and what you know about the philosophy of the cache. The next lecture we're going to explore why the cache was implemented, and from the CPU architecture, the philosophy point of view.